So now we put in our given information for the problem that we have. The depth is 6.5 meters, corresponding to the altitude of this solid, or this region. Length, width, 8.1 meters and 7 meters. The length and width give us an area, when we multiply them, of approximately 57 square meters. Multiplying that approximate 57 square meter area of the base by the altitude gives us the volume. And multiplying that out, we get, I think, approximately 370 cubic meters. Check my arithmetic on that. Okay. Now, the mass then of that much water at 1,000 kilograms per cubic meter, and that's a density of water, and everybody should know that. Everybody over the age of 12 should be familiar with that. But familiar or not, that's it. 1,000 kilograms per cubic meter multiplied by the 370 cubic meters means we have what? 370,000 kilograms of water. Now that water is being pulled down by gravity. If there's nothing there to prevent it, it would accelerate downward at 9.8 meters per second squared. So it must be experiencing a force, according to Newton's second law, equal to its mass times that 9.8 meters per second squared acceleration, and that is its weight. The rectangular region here will exert an equal and opposite force. So the force exerted by the rectangular region is equal, the magnitude of the force is equal to the magnitude of the weight, which is 370,000 kilograms times 9.8 meters per second squared, which is approximately 3.6 times 10 to the 6th newtons. And that's the solution to the problem as stated, although we can certainly go a little further and ask, well, what is the pressure on this region here? Well, pressure is force divided by area, so we can, and I'll use a different color because we're extending the problem a little bit. The pressure is then the force divided by the area. Now this would be an average pressure. We take the entire force over region, divide by the area. Excuse me, we get the average pressure, but by the conditions of this problem, this whole rectangle is at a uniform depth, holding up a uniform area or region of water, and we can say that the pressure is uniform. I'm not going to go into too much detail about that, but that would be our reasoning. So that's what? That's 3.6 times 10 to the 6th newtons divided by the area of this thing, which we said was approximately, so we'll say this is approximate, 57 cubic meters. Okay, so, well, we divide that out, and let's see, we're going to get something times 10 to the 4th. It's going to be a little more than 6. So I'm going to say about 6.3 times 10 to the 4th newtons per meter squared. Now I wrote 57 meters cubed. That's not right. This is 57 meters squared. It's square meters, so that our units do come out newtons per square meter. And again, you can check my arithmetic on this division. But that would be about 63,000 newtons per square meter, which is 63,000 pascals.